Hey everyone, so I'm in Vancouver, British Columbia. I've traveled all the way to the West Coast, and I'm here at Pantheon. They make some really cool printers, but I'm outside their facility. So I'm gonna go find a random employee who's gonna give me a tour of this place. You.
Hey.
You, what do you do here?
I'm the founder.
What's your name?
Bob.
Good enough, come with me.
All right, let's go.
So first off, what is Pantheon? Who are you guys?
A bunch of friends and I had a manufacturing company, realized that 3D printers kind of sucked for running every day on important things. So we started building our own printers, and eventually people wanted to buy them. So now here we are.
And these are the printers. These ones are ready to ship, it looks like.
This is our final testing station. So before every printer goes out, we run about 2 days of testing, general functionality, make sure everything works, double check and validate all the tolerancing of the parts coming out.
So these are the Pantheon HS3. These are the main printer you're known for.
It is the only printer we currently sell.
So can you tell me about the printers themselves? What kind of specs we have? These look beefy as heck. And if you watch the channel, they sent me one earlier this year that I've been playing around with, and they're amazing machines. But Bob here could tell you more.
Yeah, it's like, I think to sum it up, it prints two materials, nylon or PETG, both of them fiber reinforced, and it makes really accurate, strong parts just super reliably. And they're fast-ish, like they'll do 1 kilo of parts in PETG a day or half a kilo of nylon parts a day. It is the printer for companies that don't want to touch 3D printing. It just sits there and it makes parts and you don't have to think about it.
Awesome. So you're mostly aimed at the commercial industrial market.
All of our customers essentially have a factory that they put these in.
These are some built ones. They still got the wrappers on them. So let's go take a look at some ones that are in progress.
So we've got production in here. The middle is really final assembly. All the printers start off as essentially our motion plate. So this design is actually patent pending now. All the precision from our machines comes from this single setup machine top plate. And this really helps us make sure that it aligns everything really well. And if you ever have to service it, it's every part of keeping the motion system in true is built into this single feature.
So everything here this is a 20 millimeter thick, it looks like?
It's about 20 millimeters. I think it's actually half an inch because we've moved to North American manufacturing recently. All the ball screws and guides on here are from Taiwan, and the motors are from Technics in the US, which are some of the best servos we've ever gotten our hands on.
And this looks like that's just an engine
voice.
Yeah. So how come you have it on that?
Okay, so it's a Summit Racing diesel engine stand. These things are heavy. Like the finished printer is like 160 pounds. So this lets you rotate it with a worm drive. So when you're assembling these, you can get to any side you need without needing help to flip or rotate the machine over. The brackets themselves, they're like 1/2-inch steel plates. And I personally welded all of these up.
Okay, let's check those welds out.
Oh God, it's embarrassing.
Yeah, that's why grinders and paint exist.
Yeah, no, these are internal tools. Don't look at them.
And so this allows you to basically assemble the entire motion system on this one plate. You can flip it and off you go. And then once you're done with the motion system, we move on to the next step.
Yeah,
right?
You can actually see this is what the machines look like as they come off these stands. By the time they're coming off these engine stands, they're like powered on. We actually run the motion system before we set them down.
Oh, so yeah, because for those that don't know, you can actually, obviously that's missing a bunch of parts, but that could run as a printer standalone without any of this part.
Yeah, well, all of this goes on before you even take it off.
Really? So you build it all on the thing and then you lower it onto the table?
We build it all on the thing. We power it up for the first time on the thing, and we run a basic run-in of the motion system while it's on here. That way, it's easy for us to rotate it, look around.
If you have to fix something or adjust something, it's easy. Nice.
Yeah, it's still pretty low volume, so we want to give that much detail to every machine.
And this one is nice because you have the whole back off here, so we can take a look at the entire electronic system here. So some of this is just off the shelf. That's just a Picture Tech Manta. We have a 750 watt power supply. That's beefy. Why is the power? This isn't a mains bed, right?
No, so everything's 24 volts, and it's really just a regulatory thing. Doing doing mains voltage across the machine makes that a nightmare. So sticking with 24 volts for everything is a regulatory requirement that makes things just easier for our teams to deal with.
That makes sense. If you're selling commercial, international, and whatnot, it's regulatory.
You can lick it anywhere but the mains, and it only hurts.
Now, this has servos in it. So how are you making this off-the-shelf Manta board, which is running Clipper, talk to the servos. We have, what's this?
Yeah, so we have an adapter board here. It's essentially, I think, some like, it's a bunch of octocouplers for safety. I think there's some like voltage shifters in there because I think they want to communicate on at like different voltages, but we're still communicating to the servos with step and direction.
Okay.
So like to the Manta, it doesn't really know that it's not a stepper. All the servo stuff is handled on a controller on the servos themselves. That's what makes these ClearPaths so awesome. They're kind of just drop in. And then there is a SPI connection going from the servo back through so it can report things like errors, load. You know, if we ever lose positioning or overload the servos, the printer knows and it'll do something about it.
And then we also have this is a little power distribution board as well. That's a custom PCB. And that's for just cleaning up the power and power distribution, basically?
Yeah, like it snubs a bunch of back EMF from the motors, from the servos. There's a giant cap on there to smooth some things out, especially when these guys, like, they'll do weird things sometimes and pull, like, essentially a bajillion amps for, like, 20 milliseconds.
Okay, because these book, even though, like, your tool head is quite massive on this machine, and I've had comments on, oh, it's so heavy, but with ClearPath servos and ball screws, it doesn't really matter how heavy the tool head is.
Yeah, like I think we're accelerating at like 12,000, and like the top speeds are 600.
Okay.
Like it's not like the fastest thing out there, but it's like it's a semi truck. It'll do that speed all day without any service.
Wait, and you don't have belts. You don't have to worry about bouncing or bounding or anything.
No, and like they're actually like preloaded ball screws too.
Ooh,
so
awesome.
They have no backlash.
So we have the mostly completed machine here, and then this one looks like it's pretty much ready to go. So we do have a camera in here. It's a Logitech C920, it looks like.
Yeah, it's good enough.
Yeah,
like it has really good low light performance. So if it's dark, just a little bit of light and you can see what's going on. It's definitely not the best solution, but it's the one that works right now.
Awesome. And this looks a little different than mine because your beds are now much thicker. Those are beefy beds.
We've gone to 16 millimeter beds recently. It's just a little bit less sensitive to how much spring tension we put on. You know, going from making a few of these a month to making 10, 20 of these a month, we're just trying to design our way out of things that require a lot of like attention and craftsmanship. Pretty much that, like you can run more spring tension and they don't bend. And bend in the sense of like, if you over tension our 10 mil beds, like the corners can deflect like 20 to 60 micron. It's not a crazy amount, but for the tolerances we're trying to hit, it still impacts the end result.
For the tool head, we'll go back to this big beefy chonker here. What can you tell me about it?
I guess like, well, it's CAN bus connected. It's got quite a few analog sensors on it for strain and a few other like fun temperature things. So we needed the tool head board because we have analog sensors and we can't run those very far. And the rest of the tool head is really meant to be like easy to service, reliable, and just stiff at the end of the day.
And that is a custom tool head. Now, it's not Slice though.
Well, we license a patent from Slice. Okay. So the 4-tube thermal interface we really like. And we worked with Dan at Slice, which has been awesome and just giving us a very fair license to be able to use that. We do build our own kind of custom hot end off that.
Okay, so you do machine your own hot end, but it is based on Slice patent there.
Yeah.
And what kind of flow rates are you getting out of these right now? Because those look like they run hot.
Yeah, they like as far as temperature goes, there's like technically it'll do 500-600 Celsius. We don't print there. Flow rates in like the 25 to 30 millimeters cubed per second with the 0.4 nozzle. So like I was saying earlier, like it's about a kilo a day of PETG parts or half a kilo a day of nylon parts.
So these are some nearly finished machines in progress. So on this side here, we have the sub-assembly area though.
Yeah, so this is for like this station's for assembling the filament cases. I think you saw a few upstairs, but you know, here's lingering parts for a few. And okay. We're actually running low and waiting on a restock from one of our sheet metal vendors. This is where we build all of our electrical panels. It's just pretty standard, like small manufacturing stuff. Everything close by, some clamps to hold stuff down, finished panels essentially just go across the hallway and go through into final assembly.
So everything gets sub-assembled here, you go onto the shelf, and then it goes to final assembly in the middle over there.
Yeah. Oh man, when we were first, this is like our 4th layout for the production line. How we optimized it was we gave everyone pedometers, and we essentially tried to figure out which tasks required the most amount of walking. And we built our production around minimizing the amount of steps you had to take in a day.
That's actually pretty clever.
Yeah, it helped us get down from about 16 and a half hours assembly time down to just over 8.
Wait, it only takes about 8 hours to put one of these together?
It's 8 hours and 25 minutes-ish from like the top plate getting bolted to this and the machine making it into testing on the other side.
That is not bad.
So like if for one person, it's about a printer a day if you skip lunch.
What is that? Why do you have a giant tower of filament?
I just got back from San Francisco. This is the first time I'm seeing it. I have no clue. It's hilarious.
Okay. And just something to add here, like this is like B-roll cut, but like so many of the tools and like little things that they use to build their printers are printed on their printers. Like we got hammers and holders and storage, and it's actually cool to see that they're using their printer to print stuff to build the printer in their own production line. It's actually pretty cool. So back here in a corner, this is something a little... This is one of those things that you don't need anymore, but you don't want to throw it out. This is like your original design though, right?
Oh
like,
yeah, that was our first kind of like, it was our first prototype of how do we build a really reliable 3D printer on ball screws and servos. We first got this running like 2 days before Christmas in 2019.
So it's just a piece of history that
we just can't throw it out.
Aw.
We love it too much. The first time we ran this, we didn't have a heated bed. So it was just me holding a blowtorch underneath, making circles.
You've moved on a bit from there.
We've moved on a bit.
So now we have this area. So what's going on in here?
So this is R&D. It's kind of chaos at all times because it's really hard to be creative and clean. But if we go through here, these are all machines testing some version of software, firmware, or new tech. These all have funny names. These are kind of like the bastard machines. This one's called Rusty. It got one of our freight providers left this in the rain in Florida during the summer for like 6 weeks. And everything that could have rusted is rusted.
Oh no.
We took it back and like it still works fine.
And if it works, it works.
Yeah.
It's got some character now.
It's got some character. So these 3 machines here are testing new hot ends in development.
And you have your new hot end right here, actually.
Yeah, so this is like the, it's, you know, like honestly, the hot end we had before was like 3 Band-Aids on top of each other. So
but it does work.
It does work.
It works great.
Yes, but it's not very elegant.
And it could work better.
It could work better, and it could be, honestly, it could be cheaper and easier to manufacture. So we've just modified the nubs that we screw in into like a monolithic part that's machined out of copper and plated in nickel. And we've designed our own, we designed a new cold end that just has a lot more surface area.
Okay.
One of the problems we were plagued with for a while was cold end jams, just because we couldn't get enough cooling into here. And like if you look at our print heads, they have for all the flexure mechanisms to work properly, there's just not very much space to get air through.
This one's looking different than that.
Oh yeah,
What's this?
This is another hot end design we're playing around with. It's essentially...
Wait a minute. So let me just, for those that don't know, my background is injection molding. This is just a hot drop.
Yeah.
This is just an off-the-shelf hot drop.
More or less.
More or less. So this is something new you're playing with?
Yeah, I think like, you know, for a long time, we try to make the perfect hot end to do everything. And it became kind of a Swiss Army knife.
Okay.
And going forward over the next year, we're going to be branching out to like essentially a specific hot end for 0.4, 0.6, and 0.8.
Okay, so different hot heads for different use cases.
Yeah, and like essentially one's going to be about a 20 millimeter melt zone, one's 30, and one's going to be about 50.
Oh, nice.
And right now, this 20 millimeter melt zone, we're able to do about, you know, like a kilo a day of PETG.
Okay.
The 0.6 with the 30 millimeter is going to be able to do closer to 2 kilos a day, maybe like 1.6, 1.8. And the 50 millimeter melt zone with the 0.8 nozzle, we're targeting and testing 3 to 4 kilos a day of deposition.
That is a lot of filament.
This is one of our interns projects. Michael just took all of our old test hardware and threw it on an Ender 3. It's pretty hilarious.
That is, okay.
It's the beefiest Z on any Ender 3 in the world.
That is a full-on proper ball screw on an ender. That's not overkill. That's not overkill.
Well, we don't have any lead screws in the building, so like that's all there is. Like it's.
I mean, if you got nothing else, you might as well.
You kind of just work with the tools you got.
And then these are your new dry boxes, right?
Yeah. So this is the next iteration.
So a little bit easier to manufacture, seal a little bit better, kind of thing.
Yeah. We also think they just look cooler.
I do like those latches.
I know.
That was actually a really...
Stanley spent way too long on that latch design.
I
think Michael and Stanley spent like, there was 20 iterations of latch.
Oh yeah.
Isn't it satisfying?
That is nice. That is very satisfying.
Yeah. So we had some problems with our old design where the lid hinged down, where every lid had to be, so the lids couldn't be flat. They had to be like a curve. So it would apply even pressure to the ceiling band.
Oh, okay.
And the only person in the building that could hand bend the lids was Stanley. So going from like needing 100 dry boxes a year to needing 1,000, we can't rely on our head of mechanical to hand bend lids anymore.
Fair enough. Fair enough.
So this is a more robust design. We think it looks a bit better. It's also just, it seals really good.
Okay.
I think we pressurized a few of these to like 5-6 PSI and they held for like 24 hours.
Oh, that's not bad.
I know, we really want to shoot
You're not going to have moisture coming in at all with that, pretty much.
No, we really want to shoot a video of a fish tank with it inside printing out of.
And then we have, you guys like playing with bikes, don't you?
You know what? Our entire engineering team rides motorcycles, and we kind of use motorcycles as a test platform. I think like this, we have this internal kind of mantra that like, if you don't trust your life on a part, neither will our customers. So we have this weird thing where we take that literally. Like if you won't print motorcycle parts and then ride them, you don't actually trust them. And it's been really useful because it kind of helps put your immortality into the work you do.
Also, to go along with all motorbike stuff, you've been playing around with some mountain bike stuff here too.
Yeah, we're on quite a few iterations at this point. They've all exploded for different ways.
There is a lot of force that goes involved with these parts though, right?
Yeah, we came in a little bit ignorant to how hard this would be. We've realized that there's a lot of, aluminum and titanium cranks that also tend to explode when you take them off a 20-foot drop. You can see that we're going a little bit beefier now, just in case.
Yeah, that's a lot of beef.
Yeah, this one passes all of our software simulations. We'll be testing it in a load tester. We're pretty confident that this design is going to make it down a Trail of North van.
Oh, nice. So this is basically just using your machines to see how far you can push the material you're developing them for.
Exactly. Like like I said, like we eat our own dog food. It's really hard to talk to our customers about what you can trust our parts to do if we, don't do it ourselves.
Yeah, so you have real world experience with how capable your machines are and the parts they spit out. And then back here, we have a bunch of machines.
Yeah, so this is our kind of production-y print fleet. So this is what runs all the parts for customer samples, internal projects, and everything for the factory back there.
And this right here, this is actually the very first Pantheon machine I saw when I met you guys at Rapid in 2022.
Yeah, it said Pantheon. Well, it says Panth now. This was the Rapid machine.
This was your first HS3, right?
It was one of the first. I think this is the first machine that we felt comfortable showing publicly.
Okay.
It's kind of beat to shit now. The main motion system hasn't changed that much.
Yeah, you can see where everything has come from in the current iteration of the machine.
Yeah, like on this machine was using a Duet. It had like 30 cables going to a print head. I think we were using some like E3D Chimeras at the time before we developed our own print heads. We've just kind of iterated and just kept solving problems as stuff broke over the last 2 years. And now the machines are they're pretty reliable. Like you can kind of just throw stuff on them and they just work.
Yeah, that's what your customers want essentially, is a machine that's as close to a turnkey solution with FDM as you can get.
Like our customers are not 3D printing enthusiasts. They're manufacturing businesses they just want, all they care about is what is the cheapest way to make a part that's good enough. Throughout a combination of all the stuff we've done, you can start replacing machined aluminum and die-cast aluminum parts with our 3D printed nylon. And that's really all our customers do with it. It just sits there and prints nylon parts that used to be metal.
And then we have a whole bunch of filament here getting dried.
Oh God, so that dryer kind of sucks. in a panic, we built a bunch of, these are air fryers that we modified into dryers. So this is trying to figure out how to build a good dryer.
So that's something you're working on, right?
Yes, we'll have our own dryers available in the next quarter. We have our first engineering samples. We're waiting for parts for it that are just on a boat right now. But honestly, Ninja air fryer with an Arduino to keep it from turning off, it's pretty good.
And if it works, it works.
Yeah, it's a lot better than most filament dryers you can buy out there because that actually goes hot enough.
So that was a tour of the production floor of Pantheon. Upstairs is just a bunch of offices.
It's offices and all the secret stuff.
Yeah, which unfortunately, I've seen it. It's really cool, but I can't show it, unfortunately. And then I think in front of us here is the door out of here. And that's it. So thank you, Bob.
You're welcome.
Take
Anytime.
Care. Take care. Cheers. I can't see anything.
God, it's really bright out.
It's bright.
The white wall is terrible. You can't look away.
Can't see anything.